Okay, we're looking at this polynomial. Specifically, it's a quadratic, and we are asked to factor it. So that is the directions, just factor. We want to create multiplication. Our final answer will be like a binomial times a binomial. Now, this is from lesson 2.7. 2.7 includes the special patterns. So you can just use the skills that we have, but ideally what we're doing is we're looking for this particular pattern. Something squared is our first term, and it's looking good here. So we got an n squared and 25. It's the same as 5 squared. And then we want a perfect square also at the end here. So something to the second power equaling this, which is also looking good because 4 is a perfect square. And then let's see, this is a plus in the middle. So we would want plus 2 times whatever this first thing is, being raised to the second power, times whatever that second thing is, being raised to the second power, the thing on the outside. So the pattern really looks like this, 2ab plus b squared. It's perfect squares bounded on the outside. So the first term and the last term are perfect squares. And the middle is double the first thing times the second thing. If that happens, you can immediately jump to this as your answer. It's whatever's being raised to the first power or the second power here, a, whatever's being raised to the second power on the end over there, and then the symbol here, this happens to be a plus, so it's plus right between them, and then the whole thing is squared. So if we can identify that pattern, then we don't have to set up our area model. So that's what we're looking for here. We're looking, can we make this something to the second power? Can we make our 4 something to the second power? And we definitely can, right? 2 squared is 4. This one right here, we definitely have n to the second power. There's a number 25 there. And if you don't know what a number times itself is 25, you can always get there with the square root. The squared root will undo the square. So it's 5. So that means this is 5n times 5n to get you 25n squared. So we're just checking the middle piece. The middle piece is 20n. In order for it to fit the pattern, it needs to be 2 times this whole piece, so 5n, times this whole piece. So we just work that out to see that ends up being 20. 2 times 5 is 10. So we got 10n times 2. Well, 10 times 2 is 20. Hey, so it works. It matches. Everything fits the pattern. So I really don't need to set up my area model. I can factor immediately because it's going to be this thing as my first term and this thing as my second term added together in a binomial, 5n plus 2 quantity squared. And I have factored it. I've created the multiplication. Now, there's a couple things you could do to prove it. You can multiply 5n plus 2 times 5n plus 2. So I could do, 5n plus 2 times 5n plus 2. And I could set up a little area model to make sure that that got me back to here. But I wanted to show you here that you could take the same polynomial and we could factor it just using our regular methods. And we will get the same result that we had here, which is 5n plus 2 quantity squared. So when I factor this, I put my n squared term here, 25n squared. My constant goes down here. I set up a little diamond problem because diamond problems have a sum on the bottom and a product at the top, and the two numbers outside have to fit. They have to multiply to get that number, and they have to add to get that. All right, so we got a sum, and we got a product. And I know that whatever two terms I need here have to have the sum of 20n, and they're going to have to multiply together to have the same as this. So 4 times 25n squared is 100n squared. So I use that diamond problem setup to help me figure out how to split up 20. Let's see, I need the factors of 100 basically that will add together to get 20. So that's going to be 10n, 10n. It's all positive, which is nice. So they go here. And let's see, now I need to factor this. I need to look at this row as the entirety of 25n squared and 10n. And I need to see what goes into both of those terms. And I'm going to put that on the outside. So 25 and 10, the number that goes into both of those is 5. N squared and n goes into both of those. I'll do the same thing here on this column. So like looking down, what goes into both 25n squared and 10n? Well, 25 and 10, 5 goes into both of those numbers, n squared and n. n goes into both of those numbers. Now I'm just filling in my area model for what I need here. 5n times what is 10n? That's got to be a 2. 5n times what is 10n? That's got to be a 2. So look, you can see that I got 5n plus 2 times 5n plus 2. It is the same answer. When you're doing this yourself, you certainly don't need to solve it twice. By the way, this can be rewritten as 5n plus 2 to the second power. This is actually the better answer. This is the better final answer. So you can see I get the same answer whether I go through sort of my more standard ways for factoring or if I go back up and use the shortcut. I recognize the pattern and I can jump right to here. It is the same answer. Okay, I hope that's helpful. Message me anytime with questions.